Hello everyone, a warm welcome to the explanations part of the quiz on word problem basics like percent and interest. But yes, we had also some other questions on sets and like other topics which are very critical on GMAT. So in this part of the video, we will go through the explanations of the questions. And again, as I always do in my previous quiz explanation sessions that I've taken, I'm not just going to limit myself to just solving the questions. I will try to help you understand and learn things that will help you in any other question that you're going to do at your end, which is definitely much more important as a skill that you would want to kind of develop overall. Okay. So first of all, before I get started with the explanations, congratulations to Harsh, Vivek, Aman, and Only Strongs, who are the first top four students who have done well in this quiz. So very heartily congratulations to you. You've done a really good job. Harsh works with me for GMAT prep, so I'm really happy. I think you're the same Harsh Thakkar. So I'm really happy to see all of you doing really well. And let's get started into the explanations part. So a quick intro about myself. Those of you who don't know me, I am Piyush. I'm going to be your main host, and I have about 11 years of experience mentoring students targeting MBA schools globally, like tier 1 schools globally. You think of a B school, I've sent multiple students to the school over the last 11 years. I have prepared and taught for both CAT and GMAT. CAT is an Indian test. GMAT is a global test that you guys are preparing for. And I've scored a 740 on the GMAT Classic and a 99.9 percentile on CAT. And personally, I love analyzing trends and data. So I help people prepare for the GMAT. Like I take help people with the Quant and DI, and at GMAT is we help people with all three areas. But personally, not just helping with the Quant and DI, I love analyzing data to come up with trends and come up with a lot of strategies. And I've done some of the videos on test taking strategies as well that you guys can watch. If possible, I'll just share the links of that in the chat as well. Okay, so that was a just quick introduction about myself. Let's get going with the the first question itself. So I'll just give me 1 second, guys. I'll just remove the banner here so that you can see the question properly. I think it should be better visible now. Okay, so let's start with this one. Now, this is a data sufficiency question. Since all of you have gone through it, I'm going to do it a little faster. Slightly straightforward question which asks us which of the two investments between J and K, the annual rate of return greater. So I am not worried about the absolute interest. I'm only talking about the rate of interest. In which of the two cases the rate of interest is greater? And it's a yes no type question. Now, that is something which is very important for you to identify and observe, especially in DS, that whether the question that you're dealing with is a value type question or a yes no type question. Because if it is a yes no type question, you might as well get the answer without even knowing the values, okay, the exact value of the interest. So that's something which is important, and a lot of people get tricked and trapped in that trap. So just register that well in your mind. Now, when you look at statement one, it tells you that type J returns $115 on 1000 and type K returns $300 on 2500 for any period. Now, my question to you guys is, do you need to calculate the rate of return in this case for J and K? Do you need to go ahead and do the math and calculate that, okay, J gives 11.5% return and K gives what, about 12% return? Do you need to do that math? I would like to hear from you in the chat, guys. If you can hear me, I hope you guys can hear me and see me properly, I guess, right? I didn't ask for that audio check, but I hope you guys are able to hear me. So I would like to hear from you. Do you need to do the math and actually calculate the rate of interest in this case? Let's see a yes or no. Okay. No. Good, Atul. Thank you so much. You're an angel. I thought there was something wrong with the audio. The entire audience is mute. I hope you're able to hear me properly, all of you. So there is no need to do that. Please understand, this is a data sufficiency question. I don't need to find the answer. Now, the question is a yes-no question as well. So I know that I can find out the rate of interest for J and for K using the values that are given. And since I can find out the rate of interest, I know that one of them has to be greater, right? Like the answer to this question has to be a definite yes or a definite no. So I don't need to proceed beyond this point to eventually actually find the values. That's a very important learning for you guys. And again, please understand, guys, I'm not asking you to cut corners. Asking you to use your logical thinking to stop at the right point. In DS, you should solve till the point you feel 100% confident. Once you're 100% confident that after this step, the next two steps should give me the answer, you can stop at that step itself. You don't need to do any further, because if you go any further, you are possibly wasting a lot of your time doing that. But yes, you need to go to the point where you feel 100% confident. If you don't feel 100% confident at this stage, do the math, calculate the numbers. But if you're logically sound and you think logically, you will be able to understand that I don't need to do the math. That's an important lesson that I want you guys to understand. Okay. Now I go to the second statement. So statement one is definitely sufficient. I'll go to the second statement. It only tells me the rate of return from K. Now that doesn't help me in understanding which one of the two is greater, because I don't know the rate of return from J just from statement two alone. So statement two is not sufficient. One is sufficient. So my answer is option A. Okay. Straightforward question if you use that logic. Now let's come to question number two. Now, in question number two, like there are multiple ways to do this question. I generally recommend that in any word problem, especially word problems of this kind, which deal with percentages, profit and loss, like basically percentages or ratios, it's always better to use numbers to solve, and they make your life easy, and also visually represent it properly. So I'll just show you how I would do this question if I were to do it for the first time. Obviously, I've done it today for the first time itself, but I'll still do it exactly the way I did it for the first time. Okay. And you guys have to notice what I'm doing. In a certain voting district, 40% of the registered voters live in town A. So I'll assume that total registered voters are 100. So in town A, the number of registered voters will be 40, and the rest live in town B. So it has to be 60. Okay. Now this is the number that I've assumed to just visualize what is happening here. Okay. In the last election, 70% of the registered voters from town A voted. Okay, so how many of them voted? 70% of this. Now, 70% of this is 28. You can do the math by taking rough notes somewhere. But I generally look at it this way, that 10% of 40 is 4. So 70% should be 28. Okay, 4 into 7. Simple. If equal number of registered voters from both towns voted, that means 28 also voted here. Approximately what percent of registered voters voted from town B? So approximately what percent of registered voters voted? So voted divided by registered into 100%. Okay, that's how you do the math. Now after this, it's all about cancelling out the common variables. So you'll get 140 by 3, which is approximately 47% if I do the math here. Okay, so what I want you to understand is, in this question, if you use numbers, it's very easy to answer, because this question is only dealing with all relative values, which are basically ratios. So when I'm assuming this as 100, this as 40, this as 60, all these are basically ratios. Like if total value is 100, total registered voter is 100, then the ratio is 100 is to 40 is to 60 is to 28 is to 28. That's what the ratio is. They could be like 1,000 people, then registered voters will be 400 and 600. So all of that is possible. But using variables will make it more complicated. If I use numbers, I make my life simple to solve this question. It becomes very easy to solve the question. Second thing which I wanted you to understand is that always visually represent data. Like for example, this table that I have created here, for every word problem that I do, I recommend my students to always use this table so that they are able to look at what kind of information is being asked. And when they go to the to find part, they're able to focus on that and not make a mistake in that particular portion. Got it, guys? Now, before I move to question number 3, which is a question on compound interest, I'll teach you a very important principle, which is really going to make your life very easy with calculating compound interest questions. Okay. Now, again, a disclaimer. This is not a detailed compound interest session. I won't be going too deep into it. I'll be showing you that in a little fast fashion, but I'll still ensure that I don't go too fast and I explain it in a decent way. But yes, this method which I'm going to show you is a very different way of looking at compound interest, but it is completely legit, logical, and mathematically sound. Okay, which will work on every single compound interest question. But before going into that method directly, let's understand which method I'm going to use. So there's a concept of successive percentage change. Like for example, if I increase the value of P by X% first and then by Y%, I can either calculate that using 1 plus X by 100 into 1 plus Y by 100 into P, or I can simply use this formula, which is just the expansion of the same thing that I just said, that it is equal to a single increase of X plus Y plus XY over 100%. So if you're increasing the value of P by X% first and Y% next, it is equivalent to this single increase of this. This is a simple formula that you can use, and you can also derive this formula yourself if you want to. It's a very simple formula that can be derived by you, logical formula. Now, the benefit of this is, let's say, for example, let's use this formula a little. So if I increase the value of P by 10% and then by 20%, and if I use this formula, it will yield 10 plus 20 plus 20 into 10 or 10 into 20 by 100, whatever you want to write, the order doesn't matter. It will give you a 32% increase. You could have solved this in other ways also, right? You could have taken 100 as the base value, then it becomes 110, then it becomes 132. I understand that. But this formula will be super helpful in working with compound interest questions. And I want you to understand this logical point of view of compound interest. See, the general formula that is there for compound interest is a very, I would say, intimidating formula, right? It's a very complicated formula. To just present this formula, write this down, a lot of people take a lot of effort, and you don't even realize you end up wasting 1 or 2 minutes just because of this formula in compound interest. On the other hand, if you look at compound interest slightly logically, with thinking about successive percentage change, let's understand this a bit, okay? So if you're investing, let's say $10,000 for invested for 6% annual interest compounded annually for 2 years, let's say, okay? If you're investing it for 6% annual interest compounded annually for 2 years, what is happening? Understand it this way, that in the first year, your value of the money is going up by 6%. Again, I'm not asking you to calculate 6% of 10,000 right now. Don't do that, okay? Let's understand the concept. So in the first year, my value of the principal is going to increase by 6%. And since we are talking about compound interest, the value in the next year is going to increase by another 6%. And successively, like on the increased value, because interest is nothing but increase in the value itself. So if in the first year it increases by 6%, at the end of the year, the final value which is there is going to be successively increased by 6%. So I can use this formula that I just learned, and I can tell that my total effective interest is going to be 12.36%. Okay, that is my effective interest. This gives me directly the compound interest, guys. I don't have to calculate the amount and then subtract the principal to get the interest. I directly get the percentage return in one single shot. So $10,000, 12.36% is the interest. Now, what is the interest dollar amount? It's simple, 12.36% of $10,000, which is going to be $1,236. As simple as that. Now, imagine if you had to use this formula to do the same thing. You would have to write it like this: 10,000, 1 plus 6 over 100 squared minus 10,000. Now, imagine how would you calculate 1.06 squared, right? That's a complex math, right? You can do the multiplication normal method, but definitely you can see this is much more easier. 6 plus 6 plus 6 by 6, 6 into 6 by 100 is so very simple to do. Right? Such a simple example. The formula will take you time to kind of write it down and then solve it also. This is like a direct application of that. And please pardon me, again, as I said, it's a disclaimer. I'm teaching this a little fast. This is something which I teach to my students in our tutoring sessions directly. We don't even cover this in our online course because sometimes people don't understand that very well. So I generally teach this in the tutoring sessions itself, but this is something which can help you solve compound interest questions way faster. Let's take another example. I want you guys to try out this question. I mean, this is slightly more complicated than the previous one. I know. And some of you might not be able to do it either because there's some more learning required here, but I'll solve it. Don't worry. But I just wanted to give it a try for a minute. Okay. All right. Fine. So let me solve this in the interest of time. So in this case, there's a slight bit of complexity that now we are talking about compounding semi-annually. Now, compounding semi-annually means my amount is gonna not increase by 6%, but it's gonna increase by 3% in 6 months first, right? If you look at the formula also, what you do in the formula is you write 6 by 2, basically. Okay. So that's what you will do. And again, obviously into 100 will also be here, like the R in this case is presented in form of a decimal. But yes, coming back to this, so 6% annual interest is there. So compounded semi-annually means it will increase by 3% at the end of 6 months. And then it will increase by another 3% at the end of another 6 months. And there will be 4 such compoundings happening because we are talking about 2-year compounding, right? Two-year compounding. So I have to do this compounding 4 times. Now, some of you might be thinking, Piyush, isn't this concept going to be so difficult to apply? And this, I have to do this like so many times over, so much calculation. Now, the beauty of this is it's not that complex as it seems. If you do apply the formula, which is like 3 plus 3 plus 3 into 3 by 100, you will get that these two account for amount for 6.09% in interest, right? That's the value that you will get from this two. The good thing is that if the value for this two is 6.09, this two also should get you 6.09%. So you have the effective rate for both the periods separately. You can just combine them now. It's same as like you doing 6.09, then 3, and then the result of it with another 3. It's just too much of math. You can do this directly now. So it's just a two-step calculation. So what will be the final result of both these increases? It will be 6.09 plus 6.09 plus 6.09 into 6.09. You don't have to be very accurate with that. You can write that as approximately 36 because a very, very small number anyway. So it's going to be 12.18 plus 0.36. So approximately 12.54%, slightly more than that, very, very slightly more than that, but approximately 12.54% is your final result in terms of interest percentage. So what is my total interest? My total interest earned would be 12.54% of 10,000, which will be 1254 approximately. Again, slightly more than that, you can go with the options. And trust me, they can't give you very close choices in this because people, most of the people will be relying on using this formula, 10,000 into 1.03 to the power 4 minus 10,000 to calculate this. And calculating 1.03 to the power 4 is definitely a very difficult task. In fact, close to 12.6, like 1260 to be honest, Atul. But yes, you don't have to go that deep. That's what I'm saying. In fact, there's an official question on this. Again, because of limitations here, we can't do official questions in the quiz format. But this is the official question that I would like you to look at. In this question, if you notice, they are exactly asking you to do a similar thing. That it is asking us to calculate 1.03 to the power 4 and minus 1. It's like 100 into 1.03 to the power 4 minus 100. So instead of $10,000, they are asking you to calculate that on $100. So again, it's 12.54% of 100. If you do the math, it will be around 12.54. And if you see the numbers, it's very far away. You know it's 12.6. And this is an official question, guys. It's an official GMAT question. So that is good enough for you to answer. This is the best way to answer this. Again, when you look at this question, you won't even think of compound interest, right? Might not even think of compound interest. All I'm trying to say is that this concept of successive percentage change can be applied to make your compound interest calculations so very simple. Like even like you can easily save about a minute and a half in a compound interest calculation in the calculation part like itself, basically. And these are some of the methods. Like I always keep telling my students that you need to know these methods if you want to ace the GMAT and score well on the GMAT. So why did I teach you this? Because again, this is a question that we had in the test. Now, even if you don't know this formula, you can still solve this with the normal formula or with approximation, but knowing this just makes it easy. So in this case, they are saying 8% compounded quarterly. So compounded quarterly means 2%, 2%, 2%, 2%, 4 times I have to do because there are 4 quarters. These two combined will give me 4.04%, right? Remember, 2 plus 2 plus 2 into 2 over 100. If you calculate this, you get 4.04, right? Now, similarly, these two combined will give you 4.04% as well. And then you just have to combine these two. So 4.04 plus 4.04 plus approximately 16 over 100, which gives you 8.08 plus 0.16. So it is 8.24%. That is what your total compound interest is. Okay. And since that is your total compound interest, the amount is 10,000. The interest is going to be 10,000 into 8.24%. If you do the math, it will turn out to be 824. So my answer is D because that they're asking for the amount. Okay, and the amount is 10,824. Now imagine how easy is it to use this concept. In this question, obviously the answers are decently close enough. Like even if they give you answers like 10,900, 10,000, 11,000 or whatever, you'll still be able to get to the answer in this case using this concept. And this is like the fastest way of solving a compound interest question. Okay, I hope this approach helped you understand this. I'm covering this approach for the very first time in any of the sessions that I have taken today till date. So I always talk about this thing that if you want to really get to a 700 plus on the GMAT focus, these are some of the skills that you need to learn. Like you need to learn smarter logical methods of solving questions. You cannot go by the bookish archaic methods or that you learn. Again, I'm not disrespecting any of those methods, but since we are talking about a timed test where you have to do 21 questions under a very pressured environment in 45 minutes, smarter logical methods. Again, I'm not talking about shortcuts. What I talked about is a logical method. Shortcut is something which applies in some cases, doesn't apply in other cases. Logical methods are methods which are mathematical as any other method that you use. It's just that they're derived more using logic. So you need to be at a certain level of understanding. You can learn that and apply that very easily. So these things can actually set you apart. And that's one of the reasons why a lot of people that we work with are able to get some really fast track score improvement in a very short period of time. So I would recommend you to kind of focus on this. If you're struggling with a particular area, then try and learn better methods overall for this. And again, in case you want to connect with us, understand how we can help you do that, feel free to schedule a call on my calendar. I've shared the link for the same in the chat here. You guys can go ahead and schedule a call in case you want to understand what are the other methods, how you can learn those with GMAT Viz. I'll be happy to share that with you. But the idea is if you really want to kind of go ahead and do well on the test, these methods can really, really help you. And we'll see some examples of this as we move forward in other questions as well. And not just this method, other things also. Okay, so let's look at question number 4. Now, this is a fairly straightforward question. It says that Jonathan's grandparents lent $10,000 to Jonathan at a simple annual interest rate. So simple interest is always easy of 10%. He pays them back 5 years later. How much do they receive? So in case of simple interest, the formula is very simple. P into R into T by 100. Or even if you understand it logically, simple interest is just 10% for 5 years. So total interest earned is 50%. So I can do the math here. I can calculate it if I want to use the formula directly. I can do those using the formula itself. And if I do the math, I will get the value over here as 5,000 basically. Okay. And then the total amount generated is 15,000, which is 1,000 into 10,000 into 1.5. Or if you use logic, you will understand that the simple interest earned will be 50%, which is basically 0.5 times the initial amount. So the initial amount into 1 plus 0.5 is my answer, because 1 plus 50 by 100 is what you will do to find the total value, and you'll get that directly in option C. So fairly straightforward question. I could see that most of you got this right. Also, none of you made a mistake with this question either. Now let's go to question number 5. Now this is another data sufficiency question. And a lot of people got this wrong when I was looking at when you were attempting this quiz. I found a lot of you made like some mistakes in this, because what happens with data sufficiency is that sometimes people get into a habit of analyzing the information at a surface level. They look at some piece of information, they think there is new piece of information related to what I need that is given to me, and using that I might be able to solve it. They don't think it through sometimes, and that costs them dearly in the test, because they make mistakes which are unnecessary in DS, and you don't even realize that you have made a mistake. So in DS, I always recommend that you should not cut corners ever. It's very important that you should never ever cut corners. So I'll just help you solve this question. So this is how I will go about it. If 25% of a company's employee are women older than 30, what percentage of the men employees are 30 or younger? So this is the non-overlapping set question. So I'll simply draw a table with a MNW in the columns, and in the rows, I will simply write age is less than 30 and age is 30 plus. Okay. So if I assume the total number of people to be 100, this information gives me that 25% of company's employees are women greater than or older than 30. So 25 out of this are women who are older than 30, right? That's what I know. And they're asking what percentage of men employees are 30 or younger. So they're asking me this value as a percentage of total men. So for this, I either need directly the percentage, or I need, let me write it as x and this as y. I need both x and y to be able to calculate the value. This is very important. A lot of people do not do this pre-analysis in DS. They will jump directly into statement one and start solving it, and then they can make a mistake while doing that. In fact, statement two is more common to get trapped in, but people get trapped because of that. So I need to know I need both X and Y in order to solve this question, and that's super critical for you to understand. All right, guys. So now let's analyze this a little more. Go to the statement one. And what I will do is I'll draw a diagonal here to kind of, and just you write the information of statement one in first diagonal, basically. So half of the women employees are 30 or younger. Half of the women employees are 30 or younger means half of them are 30 or older. So that means both of them are equal. So this tells me the number of women employees. This also tells me the total number of women as 50. This also tells me the total number of men is 50, because total is 100, then men is 50. But it still doesn't tell me how much is X, right? How much is X? If I don't have X, I have Y. I can't solve the question. So this is definitely not sufficient to answer the question. In this case, I cannot answer the question just with this piece of information. Okay, guys, please understand that. Now, if I go to the second statement, the diagonal I have created, to keep in mind that the information on the top, let me use a different ink color. Information on the top, which is the red color, is the information from statement one, so that I don't mix that information with statement two. Okay, so the next information I'll write in blue. Okay, the statement is in blue now. Okay, 35% of the company's employees are men of 30 or younger. So 35 of the company's employees, that means 35% of 100 are men who are 35 or younger. Correct? So I get to know the number of men who are 35 or younger from it. But it doesn't tell me about Y at all, right? I only know the information about X. So since I don't have any information about Y, I can't solve with this either. Okay. But if you combine both pieces of information, that means it is as good as like removing this entire barrier from the center. I have both X and Y with me from the two pieces of information, and I can combine them to get my answer. So hence the answer is C. All right, guys. So that is how I wanted to look at this, how I wanted to analyze this. So this is the beauty of pre-analysis. If you do proper pre-analysis, if you understand the question stem properly, you will be able to do a much better job in solving. You'll be able to be 100% confident also while solving. Okay, so very critical to do this, guys. All right, I hope this helps you in understanding the importance of pre-analysis. Okay, and one more thing, not just the pre-analysis part, but even the visual representation is super critical in word problems. Like just tables and all really help a lot. Now let's go to question number 6. Now in this question, I will use, again, as I said, in word problems, it helps if you use numbers to solve. Mostly whenever you have relative value related questions, relative value, percentage, ratios questions. So I'll do this fresh, just like I did it first time. I want you guys to observe how I'm doing this. Okay, let's do this step by step. 4 friends, A, B, C, D, appeared in a certain exams. Okay, there are 4 friends. The marks obtained by B is 33% less than A. So I'll write that down. A, B, C, D. I'm talking about marks. So marks obtained by B is 33%, 33.3% less. 33.3 is 1/3 approximately. So if I take A as 3, then B is 1/3 less than this, 33% less than this. And that means B is 2. Now, if you are not comfortable with 3, you can take 330, any other number. The idea is, if you know 33.33 is 1/3, then if the base itself is 3, then the difference between A and B is 1. That's what it tells us. So B in this case is 2. Now let's read further. And 50% less than C. So B's score is 50% less than C. 50% less than C, it means it's 50% of C, because 100% of C, 50% less than that is 50%. So it's half of C. So if 2 is half of C, C has to be 4, right? Very simple. And understand this, guys. These are not real numbers. These are the ratio of those marks scored by ABCD. When I am assuming this number, these are the ratios. Okay. If the marks obtained by D is at least 2.5 times of the mark obtained by B, at least 2.5 times, that means it is 5 or more. 2.5 times of 2, right? 2.5 times of 2 is 5. It is 5 or more. that is what the score is of D. Then what is the maximum percentage by which the combined score of A and C? Now, what is the combined score of A and C? That I know for sure is 7. Okay. And I always do this, guys. I'm not going to read the entire question just like that in one go. I always read and I infer based on the information that I already have. And the benefit of having this visual representation is I can keep solving as I am reading. Like, and technically it's not solving, it's like inferring. There's a difference between solving and inferring. Okay. So I'm inferring as I'm reading, and that leads me to the answer eventually automatically in a word problem question most of the times. And this is the fastest way of solving the question. And you don't really need to be fast to do this. You need to be just focused, reading, and using numbers, easier methods to solve, and automatically you'll be able to get to the result in the fastest possible time. So I know the combined score of A and C is 7. This is how much percentage more than the score of D. And what is the maximum percentage? So if I want the score of A and C to be greater than D by the maximum percentage, I need to minimize D. That is what you need to also understand. So this is the combination of maxima minima also. So what is the minimum value of D? The minimum value of D is 5. So how much is 7 more than 5 in terms of percentage? So definitely it is 2 more than 5. So in terms of percentage, this is the math that I have to do, which is nothing but 40%. I can just do this cancellation here, 40%, and that is my answer. So see how easy it gets if you use numbers relate to real life instead of trying to use variables. Now, again, some of you who want to use variables, I can show you how to use variables also in this question. So let's solve this using variables. So first of all, B is 67% of A, B is 33.3% less than A. So approximately I've written 67%. You can, if you want to be politically correct, you have to write it like this, to be honest. Yes, so B is 2/3 of A, and B is also 50% of C, so B is half of C. Then I can equate these two equations over here, 1 and 2, right? Because B is same. And then if I simplify it, I get A is equal to 3C by 4. Okay. Then I also know that minimum value of D is 2.5 times of B. Now, since I have A in terms of C, I will also bring B in terms of C, which is half of C. So that gives me D is equal to, minimum value of D is equal to 5C by 4. Then I have to add combined score of A and C, so which is 3C by 4 plus C, and that will give me 7C by 4. And then the answer is 7C by 4 minus the minimum value of D, which is 5C by 4 divided by 5C by 4. So I have to do this math into 100%. If you do this, this will become 2C by 4 on calculation. And then again, the same thing, C will get cancelled out eventually. So if you want to do this algebraically also using variables, you can do that. But always remember, using variables will make you slow. Again, sorry for that. You couldn't see some part of the answer, but using variables will make you slow. In fact, when I had to use variables, it took me at least 3x the effort compared to what it took me to solve this question using numbers. And when I work with students, I see them doing this mistake so many times. In the real test, they start thinking about variables. They take so many variables and make their life so complicated. And this is what you need to understand, guys. When you why our brain works better with numbers is and not better with variables is that in a real life, we don't use variables, right? In the real scenarios, in the real life, you don't use variables. You work with numbers. So if you relate things to your real life, your brain will work better. Like even profit and loss questions, a lot of people write the equations down and everything. And again, I'm not saying that you don't have to use equations all ever. You have to use equations in some cases. So that's an important skill you need to have. But be prudent as to, and that is what exam awareness is also, right? Strategizing or exam awareness, whatever you want to call it. That how do I decide that I should be using variables or numbers? And for that, you have to put in the effort to try and solve all word problem basic questions at least using numbers. And trust me, most of them can be solved using numbers. Some of them can't be, like you have to use variables. So there you use variables, but you have to develop that habit. The benefit of developing that habit is that there will be at least 4 to 5 questions in the GMAT. And this is something which I've experienced myself when I took the test last year, just for seeing what is the mix of questions that are coming. And most of the students also tell us that, okay, yes, they were also seeing about 4 to 5 questions on percentage, interest, profit and loss, ratios, which are word problem basic questions. And in fact, other word problems, if you include like time and work, time and distance, word problems contribution can go up to 10 plus easily, like in out of 21 questions. In fact, if you look at GMAT also in their scorecard, they say real context and pure context. Real context questions are mostly word problem questions. Most of them, like in fact, even if they say algebra against it, that's given in a word problem for you. So if you try and use numbers to solve real problems, it will just make your life so very easy. At least in this 4 or 5 questions, if not more, if you are able to save 1 minute per question, imagine you will have 4 to 5 minutes extra compared to what you're doing right now. And that is a very big edge that you can get. And that's something which a lot of people don't understand. Okay. They say, okay, they think, okay, what is the point of doing this? I am good with variables, I can solve. But understand this is a time test we are talking about. And imagine if you're able to do this not in 4 or 5 questions, but 10, 11 questions which are there for real problems, then real context, then your life will be so much better. And it can be done. Okay, so please try and understand that. That will really help you to maximize your score, not just in Quant is the most scoring area. Like if you see any person who has scored more than 715, 725 on the GMAT focus, you will always see them doing really, really well on Quant section, and even DI for that matter. But Quant is the easiest one to kind of improve your score on. Like in terms of percentile, there's a huge gap that is there between like the initial score. And again, I'll just show you that with a slide. Just give me 1 second. I think, that slide over here. Let me just bring that in. Yeah, I think this should allow the slide to appear. So, okay, wait a second. I think there's something wrong. The slide is not there. But anyway, what I was trying to say is that in Quant, between a 82 Quant and 90 score in Quant, there's a gap of 24 percentiles. So in Quant, it is actually very easy for you to kind of maximize your score. And the GMAT score, if you increase your Quant from 82 to 90, your Quant score increases by 8 points. And that 8 points will increase your GMAT score by about 50 to 60 points overall. And that's that 8 points, if you increase in any other section, it will also increase your score by 50 to 60 points, but increasing that by 8 points in any other section is very difficult, because in DI, for example, the gap between an 82 DI and a 90 DI is only 7 percentile. Like it's very difficult to get there. But in Quant, a 82 Quant and a Quant 90 is around differences there around 24 percentile points. So it's very easy, like it's more easier for you to increase your score in Quant, and these are things which can actually help you get to that perfect score in Quant. All right, guys. So with that, let's move to question number 7. Now, this question is another interesting question, and this is testing our understanding of one important skill set, which I've indirectly talked about till now, which is breaking and reading word problems. Because in word problems, when you break and read, it always helps you in solving it without any confusion and getting the answer correct as well. So just focus on how I'm reading this question, guys. Okay, and this is where I say peeling the onions. Peeling the onion is very important, and getting to the innermost layer is very important. So this is one of those questions. So it says 90. The number 90 is what percent greater than what? So I'll have to come back to that. So 90 is what percent greater than a number. Which number are we talking about? Now I'm going into another layer. This is the second layer, which is 5 times greater than what? Than this number. So this is the innermost layer. Let me solve this. 30% of 40 is 12, right? Number which is 5 times greater than 12. 5 times greater than 12 means 5 times is 60. Greater means adding. And that is a mistake which a lot of you did. Most of you, when you're solving this question, who were there in the quiz, marked the correct answer as D, 50%, because you did not focus on the word here that it is 5% greater than 12. It is not 5 times of 12. It is 5 times greater. So the number that we're talking about is 72, right? So this is 12, this number is 72. So the question now becomes 90 is what percentage greater than 72, right? 72. So it is 18 greater. We are comparing with 72, greater than 72. So 72 goes on the bottom. A lot of people get confused about what to take in the denominator when they're doing percentage questions. If you are getting confused, always remember, what are you comparing with? What the question is saying, more than, greater than, that goes in the denominator. Okay, so this is this is easy now. I have to just do the math. This is 1/4. Again, if you know 18 table, that is easy. Otherwise, you can do the calculations by canceling 2, 3, and whatnot. And then this will get you 25% as the answer. Okay, so again, very important learning from this question. that whenever you are doing questions like this, peel the onion, read it slow. Don't cut corners. Most of the people see a single line question, they get super excited. They said, okay, yeah, this is a single line question. I'll save time in this. And they read in a hurry. And they read in a hurry. They make a mistake like this. They don't read greater, 5 times greater than, they think it is 5 times off. Your entire effort goes to waste. This was a simple question which became difficult just because you did not read it right. And there are so many official questions which I can show you where just because you read it fast, you read by instead of to, and that leads to people spending 5 minutes extra on the question, guys. You won't believe me when I say this. Any of you wants to show me the proof of it, I can show you the proof. There are official questions like that, where when you read fast, you will read by default. They've framed it that way. But in reality, it is written to. It's not like it's ambiguous. It's very clear. It is very clearly written to. But you won't read to if you read fast. So don't read fast. If you see an easy question, doesn't mean you'll pounce on it. If it's a simple question, trust yourself, read it slow. You'll automatically get it right in the least possible time. That's the beauty of a simple question. You don't have to push yourself. Okay, please understand that. That's a very important skill set. All right, guys. So let's move ahead to question number 8. Now, this is another data sufficiency question and slightly complicated question as well. As we move forward, obviously more and more complex questions are going to come. So let's do this one together. In a city, certain city, the ratio of the number of people who purchase newspaper X to the number of people who purchase newspaper Y is 7:1. What is the percentage of people purchasing newspaper Y? Now, I've solved this question, so I know this is a Venn diagram question. So two set overlapping question. So I'll just draw a Venn. I'll write it like this, that X and Y, the number of people who purchase newspaper X is 7 times the number of people who purchase Y. So let's say K is the common ratio. So I can say Y is purchased by K people, 7K people purchase X. Now, what is the population purchasing X, percentage of population? To find the percentage of population, I need to know the total, right? Unless I need to know, I know the total, which is whatever you can call it, you can call it total itself, for example. I need to know K, I need to know total in order to get there, or I need to know the direct percentage itself. Let's see, let's go to the statement 1. Now, if I look at statement 1, it says 27% of the population purchases either newspaper X, neither newspaper X nor Y. So it says 27% doesn't purchase any of the two. What that means is, if I write this as A, B, and C, it says A plus B plus C is 73% of total. So let's say the total is, let's assume 100T. Let's take 100T is the total. So it says it is 73T. Now, most of the people, when they see this information, they in a rush think that 7K plus K is 73T. That's not the case. See, 7K plus K, if you're adding 7K, right? 7K is A plus C and K is B plus C. So 8K is actually A plus B plus 2C. So you can't equate this with this and say that I can find the value of K in terms of T over here. No, that's wrong. So statement 1 is not sufficient. It just tells me that A plus B plus C is 73T, but it doesn't help me in getting B plus C in form of K, because in form of T, because B plus C is what K is. So this is insufficient. Okay. Now, if I go with statement 2, the information in statement 2, let me just rub this piece of information which is given to me over here. Okay. So if I go with the statement 2 now, it tells me 70% of people who purchase newspaper Y purchase X, also purchase X. Okay. So if that is given to me, I can say that this is 0.7K. So then this is 0.3K. And I know this is 7K. So this is 6.3K. But still, I don't have this piece of information over here, 27%. This is not given to me. So I don't have any other piece of information. I can't really find, I don't really know what is the total. I don't have that information at all with me. So I can't solve this question alone with that piece of information. Now, when I combine both pieces of information, I know that this is 27T, this is 100T. I can say the sum here, 6.3K plus 0.7K, which is X, plus 0.7K plus 0.3K. Basically, this entire, sorry, not 0.3K, we don't have to add 0.7K twice. I look at the sum of these three is equal to 73T. Using this, I can find K in terms of T. If I can find k in terms of t, that's what I needed, k in terms of t. If I have k in terms of t, I can find k by t, which will give me directly the percentage value. I don't need to do the math here anymore. But if you want to do the math, you will find that k is equal to t by 10 basically. So that is something you will get from here. Okay, guys. So that's something which is very easy to solve now. But I don't need to solve it. That's the point. So the answer in this case is your both are insufficient, but C, when you combine both of them, that is sufficient. So this is one of the questions where you had to be very cautious with the Venn diagram, write it properly, draw the right inferences. Okay. Now let's get to this question. In the year-end clearance sale, a music system is discounted by D%. So D% is the discounting happening. Then it is discounted by another 3D on the previous discount amount. This is very important to read, guys. On the discount amount, not the discounted amount, the discount amount, as in whatever the discount was given. In fact, let me read it entirely, then we'll be able to solve it easily. The original price of the music system is what percentage of the final price if the initial discount percentage is 30. So let's say the initial value is $100. So if the initial discount percentage is 30, the first discount is 30%. That means 30 is the discount. So the intermediate price is this price after the first discount, that will be 70. Correct? That is 70. Now there's a discount of 3D%. 3D means D was 30%. So 3D means 90%. So the discount is 3D% on the discount amount. That means the discount is 90% of 30. That is the second discount. So what is 90% of 30? That is 27. So what is my final price then? My final price will be this minus this, which is 43. Okay. Now, this is my final price. The question is asking for what the original price of the music system is, what percentage of the final price. So it is what percentage of the final price? I just have to do this math now. Now, if you notice this carefully, this is somewhere around 2.5 times, slightly less than 2.5 times. So 2.5 into 100 is around 250, less than 250%. So I can just look at this options and the answer is going to be 233. I don't need to do even the math. And this is where again the smartness comes into picture, that you don't blindly solve the question. You can always observe the options also. If the options are close enough, then obviously you would need to do the math and solve it. But if it is not close enough, then you will have to, you can directly like approximate it just like the way I did, right? So this is how you need to solve the question. Now, the main thing that I wanted you to focus on in this question is the wording of this question. So this is a common like trap in GMAT. They make you actually trapped in their wordplay. Like this is not an official question, but in a lot of official questions, they'll make you trap in a wordplay. In fact, in this case, if you get trapped in the wordplay, you might get E as the answer. In official questions, many of them, if you get trapped in the wordplace, your answer will also not match. In this case, you'll get the wrong answer, but at least you'll move forward, right? You'll not know whether you made a mistake, but at least you'll move forward. But in the actual test, they give wordplay in the questions where you get stuck, your answer will not match, and then you'll kill another 4 or 5 minutes thinking about what went wrong. That kills a lot of your time. And in most of the cases, I've seen students getting so confused that they eventually don't even get the answer. They get the answer also wrong and end up spending like 6, 7, 8 minutes on a question unnecessarily. So the only solution to this is that in the first read itself, when you're reading, you focus on every word slowly. And some of you might think that Piyush doesn't doing that mean I have less time to solve the question. Not really, guys. You will have ample amount of time, because if you do the reading part right, trust me, guys, if you do the reading part right, you will be able to understand the question so well that you will be automatically able to solve the question in the least possible time. Solving will not take you time if you understand the question well. And there is no cutting corners on reading the word problem, because if you don't understand the word problem, how on earth are you supposed to even solve it, right? If you read the word problem wrong, there is no way you can get it right. Okay, so don't cut corners. That's a very, very, very important skill. Okay, that brings us to the last question of the day, a DS question, 805 level question. But yes, if you use logic, use the skills that we talked about, definitely becomes easier. Let's see this question. So this says if a price was increased by X% and decreased by Y%. So this is again successive percentage for a concept. So it is X% increase and Y% decrease. So what is the effective change? Effective change will be X plus y, but in this case, since y is negative, I'll write minus y plus x into minus y over 100 because it is decreasing. So in case it is decreasing, in the formula, you just replace that decrease with a minus sign. That's it. Okay, just add the minus sign. So this is asking us, basically, if I just write it properly, this is basically equivalent to x minus y minus xy over 100. So this is the net change, percentage change in the value. Now it is saying that is the new price higher than the original? So if this percentage change is greater than 0, then the new price is higher than original. If it is not greater than 0, then the new price is lower than original. That is what we need to understand. Because if the value that I get out of this is greater than 0, then there's an increase happen. That's the idea. Now, many of you actually marked D as the correct answer in this case because they thought if it is increasing by x and increasing by x and decreasing by y, just if x is more than y, then it will work basically, because then the value should have increased. And you have not used mathematics, you have not used the conceptual understanding that it's not just about x being greater than y, it also depends on the magnitude, how much greater it is. And I will see to that with maths also and with numbers also, both. You can use numbers also if you prefer using numbers. You can use algebra, whatever you prefer using. In fact, when I like, this is based on an official question which is very similar to this. When I was doing that official question for the very first time, I also kind of used a bit of numbers to kind of solve it. So it's all totally up to you. Like, you can use numbers also if you don't want to use algebra. But again, I'm just showing you using algebra as well for concrete proof, because when you do algebra, you're 100% sure as to whether you'll get the answer or not. And especially in questions like DS, you might need to be sure. So that just helps. Otherwise, you can take numbers, two different answers. You try to prove it insufficient if possible. If you can prove it insufficient, then that's the best thing you can do, right? Because if it is insufficient with two different numbers, two different answers you are getting, your job is done. You can be 100% sure then. Okay. So let's look at statement one. Statement one says x is greater than y. Now, if x is greater than y, that tells you x minus y is greater than 0. But what about xy by 100? If x minus y is greater than 0, you don't know xy by 100 is greater than 0, or like if x minus y is greater than 0, there's a possibility that the value that I get from x minus y is so big that it can consume xy by 100 easily, and you will end up getting a positive result. On the other hand, it's also possible that x minus y is so small that it can't consume minus xy by 100. For example, if you want to do this algebraically, the best way to do this is treat x and y as close to each other as possible, almost equal. If you take them almost equal to each other, x minus y will cancel out, and you will only be left with minus xy by 100 when x and y are very, very, very close to each other. So that will give you a negative result. Now, if you want to validate that with a number, you can take x as 11, y as 10, and you will get this as the result. Basically, it is 1 minus, this is 1.1. So it is minus 1.1. So it is a decrease if x is 11 and y is 10. On the other hand, if you take x as, let's say, 1 million and y as 1%, in that case, it will lead to a positive result, right? So you can do the test of extremes also. And in that case, you will understand that it is insufficient to answer this. Okay. Or as I said, you can use the math, the algebra here, to understand that it only tells us x minus y is greater than 0. It doesn't tell us anything about xy, how big it is compared to x minus y. Okay. Now, if I look at the second statement tells me x is equal to 1.2y. Now, again, two ways. You can take a number and try and solve it. I'll rather prefer algebra here. So I'm just doing that first. So if I do that, I replace this here. I get 1.2y minus y minus 1.2 times y squared over 100, right? Which will be equal to 0.2 times y minus 1.2 y square over 100. Now I can write this as y times 0.2 minus 0.012 y. Now, if you notice, this y definitely is positive, right? It's very simply given non-zero, and then obviously the increase or decrease, that number has to be a positive number, basically, because they're very clearly saying decreased by y%. So y is positive, but I don't know what is the value of this, right? If y is, let's say, 1, then this entire number will become positive. 0.2 minus 0.012, it will become positive. But if y is a very big number, let's say y is 10,000, in that case, this will become negative, right? So I don't know whether this inside the thing inside the bracket is positive or negative. So this also is insufficient. Now, should I combine both? If I combine both, you can notice that first statement is telling us nothing new, right? It is just telling us x is greater than y, which is already being told in the statement 2, right? Statement 2, when it says x is 1.2 times y, it is already telling us x is greater than y. So if it is already telling us x is greater than y, then what is the point of statement 1? Statement 1 is not going to help us in any case in that scenario. So in this case, statement 1 is not going to help. So even combining both, I'm not going to get the answer. And hence, my answer is E. Okay, guys, I hope this helped you understand. I tried my best to teach you a lot of great skills. So just to summarize, we talked about some of the very important things that you need to just go back to one of the slides, this slide where we talked about all the skills. You need to strategize how you need to solve a question. You need, in word problem basics, important to use real scenarios. That really helps you. Exam awareness is super critical. You should be basically knowing where to stop, what to do, what not to do. Very important. If the calculation is not needed, if the options are not very close, you can do approximation. If they are close, you have to do the calculations. Meticulous reading, super critical in word problems. I showed you questions where if you don't read one or two words right, you read them wrong, you can get trapped in the wrong answer. And obviously, all of this you have to do under pressure. And in doing that, smarter logical method helps a lot, because if you are able to solve questions, if you are able to solve questions using logical methods, you are able to save time in even 4 5 minutes, 1 minute per question. It's a lot of time. You do that in 10 12 questions, you save a lot of time. In fact, a lot of my students end up completing the test earlier just because they're able to solve questions smarter. So these skills are very, very critical on top of what you know in quant to actually ace the GMAT, guys. Okay. So I hope all of that was really helpful in understanding how to go about the GMAT word problem, especially the word problem basics that we talked about today. So if you have any other questions, guys, feel free to ask me on my email ID. I've always already given you my WhatsApp number as well. And if you want to check out our services like on GMAT, you can just go to our website as well. And it was great interacting with you guys. Hopefully, I was able to add a lot of value, which will help you in the questions that you're going to solve. So do your best, guys, and rock the GMAT and make me proud, right? I'll be happy to see all of you doing well on the test. Okay, guys? So thank you so much for being here today. And good night to all of you who are from India and people who are in the States. Good morning and good evening based on wherever you are. Thank you, guys. It was great talking to you. Thank you, Atul. Thank you.